Thank you. Thank you very much, Tarun, for the introduction. And thank you, Ben, very much for inviting me to have a chance to talk to all these good folks about these, I think, relatively important subjects. The company itself, LED Greenland International, is a good point of reference for the overall discussions, which are really about energy efficiency, renewable energy, greenhouse gas emissions, and how all of that ties together from a business perspective, sort of the balance between the equation of an ethical choice or ethical choices and a business sustainable model. There are a variety of solutions in regards to that. I just wanted to say again that the presentation itself is about those topics, and so it represents a framework as a presentation for all of these topics. And the way this is going to work today, at least in theory, is that there'll be short sections that I go through, and then at the end of each of these sections, there will be a Q&A section. So as we go along, if I had the honor and pleasure of being in the same room with all of you, other than the virtual equivalent of that room, then I would perhaps encourage interactive, real-time questions and answers. But since we don't have that luxury at the moment, this is why we're approaching that. So again, as you will have seen before, the topic title is Ethical and Sustainable Capitalization and Commercial Expansion During a Period of Global Climate Change. We will go through this. There's a model, an IBM model actually from the 1960s, originally developed, that basically says, tell them what you're going to tell them, then tell them what you told them. It's not actually meant to be directive in the sense of how it might sound. Rather, it's an opportunity, all things being in a circle, to start with a point and come back to the point, but always representing context. Next slide. So regarding myself, as Trina had given the introduction, my background is in a variety of topics, but originally, or shall I say in the beginning, quote unquote, my interest was in law. And so when I grew up in New England, in Massachusetts in particular, I was focused on getting to university. I started out at Northeastern University, later going to Harvard, to focus on law. But I didn't necessarily want to practice law, which is in fact what I ended up doing. Rather, I wanted to be able to leverage the ways in which law would direct you into how to use logic in problem solving and identification, and how to best frame the communication itself. So for example, one of the aspects of my background when I was at university was I realized that it was probably a very good thing if I didn't have a strong accent in the sense of from the Massachusetts/Boston area, which is where I went to university. So I went to learn the intricacies of American Broadcast Standard English, which is what I use normally, although I can actually revert back to something that would sound more as the vernacular for the city and state that I grew up in. That has all stood me well. When I got out of university, I wanted to pursue business primarily, and I had a very strong interest in technology. So all of these slides that, by the way, that you have, or you're looking at here, are meant as collateral material so that you can refer back to them should you wish to do so. Some of them are a lot more important than others, this being perhaps the least important of all the slides. So I pursued my business career, and along the way, while I was focused on technology, I also began to apply the law side of that, which is in the form of contracts and negotiations and approaches, and especially considerations as they relate to finance. So my background also includes a very substantial component part of managing companies at all levels, from CEOs to chief technology officers, in order to be able to get a more well-rounded perspective of how to develop things that were aligned with the interests that I had. Along the way, I've raised now close to about $1 billion worth of investment in companies, varying, but still having simple or similar themes all the way through in terms of technology. I had a chance to be, and an honor actually, to be appointed by Governor Brown, as Tarun had mentioned in the introduction, to be the Director of Energy Program Development, actually for the state. The position was manifest in the California Conservation Corps, but it was also under the state agencies, as in the Natural Resources Board. So these actually, in that framework, that's how I actually got a chance to meet Ben Finkelard and company, and work with the Energy Efficiency Institute. And that has been a true pleasure for me and very productive, both, I would suggest, for all the parties and certainly for the state of California, as it resulted in a number of very substantial program implementations on the energy efficiency level and also on the greenhouse gas reduction side. Next slide. So we finished that first section. I don't presume that you have questions regarding my background, but should you have them, that this is an example of the framework where we're going to be pausing at the end of each section and take any questions if you might have them. If not,
so I have one question for you, Bill. One thing that it talks about in your bio is your experience internationally. And I wonder if you're going to be talking today about primarily the market for LED green light international products in the US, although I know the company's active elsewhere. But I wonder if you would take a moment to talk about how your experience abroad has shaped your career, as well as your perspective on how, I mean, global climate change is a global problem. How, and this will bleed into your talk, I think, but how you see different countries addressing this challenge in a collaborative way.
That, of course, is an excellent question. Gets to the heart of all the topics that we're engaging in. So it is true that I have a pretty extensive background in terms of working in other countries, and certainly focusing on everything from personal interest in travel and other cultures, languages, etc., as well as sort of a centrist theme of business development on a global scale. So along those lines, the presentation today is primarily focused in terms of evidentiary, note the legal reference here, aspects which have to do with the United States market. But in fact, the market attributes that I'm describing are true for essentially all countries to a greater or lesser extent. The last time I looked, we're all on the same planet, and there are really no differences from a climate change perspective or other environmental issue perspective to a national boundary, state boundaries, or any other aspect of that. So the things are universally applicable that we're going to be discussing today. And although the US as being the largest single economy in the world, but no longer the largest emitter for greenhouse gas emissions, and other countries that are in different stages of development, there is a certain amount of equity and equitable perspectives that should be applied when considering all of these aspects. So we'll be touching on all of those things.
Thank you.
If there are any other questions, great. If not, let's move on to the core of the material. I can't see if there are any others coming up in the text thing, so.
I'll monitor the chat session,
Okay.
Bill, in case there are any questions. So
Even
I
better,
think we can go.
then I'll let you do that, and I'll focus on the subjects. But if there are any questions, please, any of you good folks, don't hesitate to ask. Let's
Went
go
too
into
far. Sorry about that.
Yeah.
Is this correct here? The correct slide?
Yeah. I am seeing right now. Hold on. I'm seeing this. I'm not seeing the slide. It should be slide number 4.
Yeah, that's what I see.
Okay, well, I'm not seeing it, but that's perfectly fine. I have it on the screen here of my own. So in this case, I'm emulating the students that may not have dial-in capability at the moment.
Very good.
I'll tell you a little quick joke here, or not joke, but a little story. So a long time ago, I was at a presentation and there was an IBM salesperson there who I knew briefly. And in the middle of a slide presentation, at that time, there weren't slides, there were overhead projectors. And during this presentation, the overhead projector lights went out, which they did with some frequency. Not our lights, of course, LED green light, but these lamps. And they brought a replacement in, and it was defective and it didn't work. So they went around so the IBM salesperson was completely unflappable, in my opinion. And so he pulled out a little handheld slide viewer, put the next slide in there, and passed it around to everybody in the room. He was very successful, ended up with making the sale. So just a little side story there. Technology is both an inhibitor and a opportunity. So it is what you make of it. So a little bit about the company. So LED Greenlight International was founded in 2006. And by the way, I'm not going to read all these slides to you, so please don't have any apprehension about that. This is collateral material. The focus of the company is really quite simple. The company itself wanted to be successful and still wishes to be successful in the commercial market, and it has been. Although it's done so on a pretty small scale relative to the larger lighting companies in the world, people like Sylvania and Philips and other companies like that. So the primary focus, again, from a technological standpoint, is that LED green light arguably produces the highest quality lighting, LED lighting products available in the world today. Now, that's kind of a grandiose, potentially, statement. But if you measure it from different perspectives, for example, the quality of the light itself is typically measured in terms of CRI, which is color rendering index. This is called high color. So all of our products are 95 plus CRI, which is a very difficult scale to achieve on an economically sound basis. All of the lighting products we have are also exceptionally high efficacy, which means lumens per watt or efficiency. In coupling with all of that, because LED Greenlight is a bespoke designer, meaning we actually design the LEDs. We don't manufacture them, but we design them and they're built to our specification. We design all of the lighting products themselves. And because we have control over those things, we actually are able to produce LEDs that last a lot longer. So all the LED products that we sell, that we manufacture, we design, manufacture, and sell, are have 10-year non-prorated warranties. So should they fail for any reason, whether that's a binary thing like they don't work anymore, like you turn the switch on and the light doesn't come on, or whether there is a qualitative change like the light dims or it yellows or whatever it may be that is not the way it originally was, we replace those at 100%. So there's no prorating in that regard. We have quite a few customers, which you'll see in the next slide. But again, our primary goals are produce the best lighting possible as equivalent as possible to natural daylight, to do so on a basis of very sustainable, in meaning the cost of ownership measured over many years is a lot lower than it is for a product that may appear to be cheaper or less expensive from a price perspective, but is often more cheaply constructed. And to be able to do this on a consistent basis for all of our customers and offer a very long-term warranty at high quality. Next slide. So on this slide, number 5, you can see some of the customers that we have. This is just a handful of the customers, but they range, as in the term international in the name, they range from different countries to throughout the United States to different kinds of educational environments, commercial environments, nonprofit organizations, hospitals, K through 12 schools, a wide selection. But all of these particular all of the particular products that we make are focused primarily on the commercial sector. It's not that we haven't produced lighting for residential environments, but our emphasis is on the commercial sector, which I'll get into the reasoning for that later. But for now, our emphasis is in that particular area. Next slide. Now, this slide is useful for a couple of reasons. One is, if you look at the photographs on the right-hand side of the slide, you'll see on the top photograph, there's a, apparently very nicely lit classroom environment. And then below that, there is another environment, which, by the way, is, you'll see in the subsequent photo, an environment which shows what the lighting looks like before that. So the idea here is that we are trying to enhance and to produce standards for what the quality of lighting should be from an experiential standpoint for any environment, whether it's an office environment or an educational environment as such as pictured here. And you can see the difference. So these are side-by-side classrooms. One, the top one is after the installation of our 95 plus CRR lighting products, and the one below is before. What you can't see is what the difference in energy efficiency and the reduction of greenhouse gas that's directly attributable to that is, which is very substantial. Next slide. So this particular slide, again, the main takeaway from this slide are the two column graphics. So on the first of those, looking from left to right, is an example of what the spectrum of lighting looks like. I mentioned high CRI, high quality light. So you can see the difference between those two products. This is also a comment on the lighting industry in general. What does the competitive landscape look like? So on the first column, you see a high CRI or high quality light. And the second column, you see a more traditionally found, very low cost LED light. And the difference is that the one on the left has, a 97 CRI, and the one on the right has a 78. So typically, other products or standard lighting products that are in the LED spectrum would be between high 70s and up to mid 80 CRI, which is still perhaps not a bad thing. But if you look at the very bottom of those two graphs, there's what's called the spiderweb graph. And that spiderweb shows you the amount of lighting in each of the color spectrums, of which there are 15. The bar graph directly above that also shows the same thing, but it's a little more dramatic when you look at the spiderwebs. The one on the left is pretty much full spectrum of light being delivered in that particular room, which means the color rendition, contrast ratios, etc., in that room are particularly good. The one on the right, less so. Next slide. This is just essentially a way to look at those two graphs a little bit more closely. But a 97 CRI, which is the spiderweb diagram below, and the bar diagram above that, this is really showing you an example of what it means to actually achieve almost 100% of the potential for light in each of those color spectrums. Next slide. This is that same two classrooms that you saw the vertical stacking photos of, but now you can see side by side, they're taken from the hallway at the same moment, what the original lighting looked like, which were fluorescent at a very low Kelvin rate. These are about 3,200 Kelvin. And then on the right, the new MLC2 standard, which by the way, was originated from the UC Davis California Lighting Technology Center. And our lamps have been recently selected as a provider for that standard throughout the state of California for the UC system, California State University system, and the California Community College system, and the Department of General Services, and by the way, all the other state agencies that might want to camp on that and will camp on that. It shows you the difference between the two lightings at the apparent level. On the inside, if you're actually in those rooms, the difference in being able to see the contrast on a sheet of paper between black and white, pardon me, 1 second here. As I said, applying some lubricant. You can see that there really is quite a different contrast, but what you can't see quite as well is how true the colors are rendered in those particular environments. It makes a huge difference. There's an old joke in the lighting industry that says if you have poor quality lighting, note the room on the right, then you need more of it. And so that's kind of funny until you begin to think about what the implications of that are. It means that often if the lighting quality is poor, you need a lot more energy to drive a lot more poor quality lighting. Conversely, in a room that has excellent lighting that approaches natural daylight, then you can see things a lot more clearly, including contrasts and colors, and therefore you need less light. So therefore, if you couple the best lighting with the best control systems, you end up with an opportunity to greatly reduce power and energy consumption and greatly reduce cost associated with that and greatly reduce greenhouse gas emissions. Next slide. So in addition to lighting products by themselves, LED green light, and again, this is all context. I'm not selling you anything. This is just context. We also have produced, which it turns out that there is a spectrum of light called UVC. Natural sunlight would include UVA, UVB, and to a lesser extent, UVC. So UVC light, if it's projected properly, and if it's in the right frequency range, can actually suppress pathogens, whether they're viruses or bacteria or any other aspect of that. But there's a couple of issues with that, which means that in order to actually do that, to produce a UVC device that will suppress pathogens, you have to be sure that you're applying it in the right frequency range that would actually affect the pathogens in the way that you would wish, meaning to disable them from being able to replicate or sterilize them. And there are some considerations for that. Next slide. There's a lot of data on this slide, but the bottom line is really pretty simple. So our integrated lighting and pathogen suppression systems use two forms of pathogen suppression. The first is airborne. So when you shed viruses, whether it's the common cold or flu or, God forbid, COVID-19, in an indoor environment, those are very light particles, and they end up, as they mix with liquid, they end up floating in the room and therefore being easily inhalable by other people. So our goal was to create a pathogen suppression lighting system that offered our LED green light, high quality lighting, which was MLC2 compliant, which is the new state standard. And in addition to that, be able to filter the air or sterilize any particles in the air, and also be able to provide line of sight suppression, which means directly under the light. So if there are pathogens in the air, they are drawn up into this device that sterilizes them, and then the sterilized air sent back into the room and to recirculate. Also, if they happen to be on a surface, then they're directly responsive to or being sterilized by the lighting itself. This is called FAR UVC. Anyhow, that's an example of that product. Next slide. In addition to lighting products, one of the diversification topics that we have is to do hydrogen fuel cells. Some of you may be familiar with that technology or not. Next slide. In any case, it is a logical extension for our particular business of being able to provide customers with energy sources that operate 7/24 by 365 days of the year that are non-polluting. In other words, have a zero carbon footprint. Even though lighting in any of its form, you can get it down to be exceptionally efficient, but you can't get it down to zero. So this is an example of another product that we actually produce as a company. Next slide. All of the products, as you may very well be aware, the number one objection to uptake of anything is whether or not there is capital available and a budget allocation available for a business or an individual person to be able to purchase or otherwise acquire or use the goods and services, in this case, lighting products and other energy products. So to that end, LED Greenlight has its own privately funded commercial funded lighting as a service system. And the main points about lighting as a service: there's no capital expenditure required up front by any customer. There is no installation costs. Actually, there are installation costs, but not borne by the customer. And there's no maintenance cost over a period typically of 10 years. So this is the kind of program that accelerates the uptake of energy efficiency, whether it's lighting or HVAC or any other product or service. These are the kinds of program availabilities that are going to be required throughout any location regarding being able to get to energy efficiency and greenhouse gas reduction goals. Next slide. Questions. So I just completed a very brief, which would normally take a day, discussion on all of the subjects that relate to what LED Greenlight actually does and why we do it. If there are any questions you have at the moment, please let us know. If not, we'll proceed.
Bill, we did have one question from Jolie, who was curious about how you kind of what inspired the lighting as a service concept, and just kind of how you came to that.
Okay, so that question is actually the central question to lighting as a service or energy as a service. Energy as a service is just a broader spectrum. So for example, if somebody wanted to purchase lighting and a fuel, hydrogen fuel cell, it would convert to energy as a service. But the reason, the way in which it was formulated was simply because there are so many objections. So we would go, for example, let's use a school district as an example. So school districts are notoriously unable on a regular basis to have enough capital to be able to afford almost anything, never mind upgrades to their infrastructure. They tend to wish to do things like energy efficiency upgrades, etc. But in order to do so, they have to basically either float a bond, which puts them into debt, or they have to somehow have benevolent, contributions or other sorts of things. But it's not likely, because they're nonprofit organizations, that they will be able to generate sufficient resources to be able to do these things. So the net result of that is that they end up doing like one building out of their 50 buildings a year. Well, do the math on that. So how, the fact that these changes affect the educational environment dramatically, as in improve them. They reduce the operating costs, which means a positive cash flow back to the customer, or in this case, the school district. All of those things are incredibly important, but there's no way for them to get there in practical terms, other than floating bonds. And not all school districts can float bonds, and not all of them have contributions to be able to do this. So to overcome that objection, we came up with this program. I don't mean to say that we invented this program, because we did not, but this version of energy as a service is uniquely ours, and the funding sources are also uniquely ours. So if that answered the question. If there are others.
Yeah, there's another question from Brent asking about kind of the international markets that you are in, which ones you're serving, and then are your sales primarily in the U.S., or do you have substantial sales in these international markets yet?
So the answer to that is LED green light, which again is part of the context framework. There's an old saying, which I should have said earlier, which is that context, although not everything, is close. And so in light of that question is particularly germane. So most of our sales are in the United States. We do have some sales ongoing in the UK, and we have partnerships, and we sell through distribution networks that are not just here in the US. So we have sales that occur in Africa, on the continent of Africa, various countries in the US primarily, and on a growing basis, we'll have more in the EU. We're not, it's not that we are unable to sell elsewhere. I mean, there's no logical reason other than the fact that we are a small company. So getting the distribution network in place that can be supported properly and be successful is the primary constraint. Any further questions on that subject?
I think there's one more question, and then maybe we should kind of move to the next section, but what are the energy savings and GHG savings from your product compared to other LED products out there?
Okay, good question. So the competitive market space, LEDs have become commoditized typically. So you can run over to your local building supply store, Home Depot, Lowe's here in the United States, or whatever other entities, and you can buy a very low cost LED light. You can sort of tell the quality of that light by what they actually offer for their warranty. So if you see an LED light, for example, all the LED green light products are rated at 120,000 plus hours. So if you do the math on that, that's like 20 some odd years worth of operation. If you're looking at, like 6 in the morning till 6 at night sort of thing, if it's a commercial application. so the competitive market also is, because it's commoditized, it's driving towards the lower and lower cost. So cheaper and cheaper constructed and designed LEDs, and therefore lower and lower color, high quality color index. So those are the kinds of things. It's kind of like almost any other product and that gets commoditized, and it tends to be a downward spiral all the way down. Again, our products, as I showed earlier, compare differently. They are different. They have a much lower cost than the cheaper, in quotes, products do over an extended period of time. So those are the kinds of things that you would see in the marketplace. A 10-year non-prorated warranty, you're not likely to find that in most commercial products. You would see something like a 2 to 3 prorated warranty.
And Bill, just to kind of, the question was about energy savings and GHG emissions. So there may be embodied GHG emissions in the product if you have to replace them, of course. And then you had mentioned that the improved color quality allows you to dim and operate at a lower power factor. So I'm assuming there's some energy efficiency savings, but those may be equivalent to the.
Right. So
yeah.
Thank you for that elaboration. So if you have a very high quality light, you can use a lot less of it, as I mentioned previously. Therefore, if your control system, available control system allows for dimming, which ours do, our standard lighting, you know, a linear tube lamp, for example, would include 3-step dimming built in. If you have 1 to 10 volt DC controls for that already in the room, you can use those with our products without any change, or you can elect for the Bluetooth mesh control system, which is fully ADR or automated demand response capable and certified, in addition to all other aspects of linear dimming. So you get a much greater efficiency from that than you do in other products. But in general, if you compare one LED tubular lamp, you know, like a replacement for a fluorescent tube, to another, you will see similar kinds of reductions when compared to fluorescent lamps. It's what happens after that. It's for example, if you replace a T8 fluorescent lamp with one of ours or one of our competitors, you will see typically that the competitor product will be running more at full capacity, full power output, whereas our products tend to be operating at about 70 to 80%, because the color quality and rendition quality of the lighting and the purity of the lighting itself allows the customer to operate them at a lower intensity. So there are both subtleties and gross attributes of energy efficiency. There's a direct correlation between energy efficiency and greenhouse gas reduction, which I will address shortly.
Yeah, we might want to go ahead and move on to the next section there. I know there's additional questions, but we'll get to them, I think. Yeah.
Okay, next slide should be number 16.
Yep, that's where we are.
Well, very good segue into the topic. So greenhouse gas emissions. So first of all, in the center of this particular slide, you can see the representation of where greenhouse gas contributions or emissions that are contributing to the overall issues are coming from. So you see the largest single sector is transportation at 37%. And there's lots of work being done in this particular area. No one company, no one entity can do all of these things, but electrification of automobiles varies from place to place and country to country. Some countries actually having determined and decided upon a date certain where all internal combustion vehicles will be replaced by electric variants. State of California also has a similar edict put out by the state, by the governor actually. But in any case, buildings which in this diagram are shown as both residential and commercial buildings, are about 26%, and industrial, which are also buildings, by the way, are 27%. So between the two of those, you're looking at more than half of the greenhouse gas emissions that are coming from buildings. The question is, what's going on in those buildings? The biggest issue with this, next slide, is how do we get from here to there in time frames that would make sense? Make sense means without causing difficulties at a planetary scale that would be difficult for the race to continue, in ways in which we normally think about living standards and styles. In the state of California, you can see the graph here. So the 2020 target of greenhouse gas reductions, this is the actual set of targets. So in 2030, the idea is to reduce to that point you see on the graph. That goal was set in the year 2000. So if you look at that time period, last time I looked, this was 2021. So in 2020, we had achieved, about 10% of that goal. So logically, in order to get to the subsequent goals, it would basically take a Herculean effort in order to be able to reduce the greenhouse gas emissions from all the different sectors in that time frame. In other words, another 82% reduction in 25 years from 2010 to 2045. This is not a small task. And we've heard lots of news about this, but the details behind this are very substantial. And I'll get into the approach to this, actually being able to achieve these goals shortly. Next slide. So the takeaways here are that there are many different ways to approach these goals. The goals are very ambitious, but I think, in fact, they're understated, in terms of what needs to be done. But they would require, some very substantial shifts in the way people think and the way people act in order to be able to achieve these things. Now, a year ago, before COVID-19 and its effect on the entire human race, on Earth and what we're doing and how we do it, many people would say, well, people just are not going to be able to change. They're not going to, be willing to make the changes required to make these things possible. Then we get COVID-19 and we see that there's a tremendous amount of change. And it has to do with the concept of being vulnerable as people and potentially losing our lives and our livelihoods. Well, the pandemic is a very small scale event by comparison to what is likely to occur and is already occurring from a climate change perspective. The difference is speed and our perception of time. From a financial standpoint, there's a circled paragraph here that talks about the fact that it's going to cost many trillions of dollars to be able to achieve these goals only in the United States. But since there's no walls or bubble over the United States, the effect of all other countries that we have on other countries and other countries have on us requires this to be a truly global perspective of application for resolution. I know this is pretty obvious, but nevertheless, it's an important contextual framework question. Next slide.
Bill, we might want to keep going here because we have about 10 minutes left. And
Okay.
so I want to make sure you get through.
Yep. All right, I'll just move right on then. So let's take a look quickly on slide 20 at the commercial market sector. So LED green light is focused on the commercial market sector from an energy perspective. And the reason for that is pretty simple. If you want to actually create a large opportunity from a business perspective and also from an energy reduction perspective and greenhouse gas emissions perspective, it would behoove any entity to focus on places or areas or sections that have the highest density of potential yield. Next slide. So in the US, again, focused on the US as the largest single example, there is right now, by the year 2040, we're expected to have about 109 billion square feet of floor space in all of these buildings. They tend to be, if you look at the definitions that are used for commercial sector buildings, it's 1,000 square feet. The increases are happening very rapidly, but the amount of energy efficiency and greenhouse gas reductions on these per square foot additions is much lower than would be expected or even represented by codes and standards. Next slide. So if you look at the overall energy consumption in the US, there's about 97.7 quadrillion BTUs of energy used in the United States annually. That goes up each year as there are more people, more buildings, etc. About 38% of that is actually from the electrical power generation side of the world. And again, there's a direct correlation between the number of BTUs produced and the amount of carbon emissions and other greenhouse gas emissions, including methane, etc. The US commercial and residential consumption is about 10.75 quadrillion BTUs, about 11% of the total US consumption, but it is highly concentrated, which means it is addressable in a much simpler fashion in terms of being able to make it more efficient and to be able to reduce its correlated greenhouse gas emissions. Next slide. That brings us to, from an LED green light perspective or a lighting perspective, what does the lighting look like in those industries? Well, you can see that red circle in the looks like a kind of an ocean graphic there. That's where we are today in terms of the uptake of LEDs. So the vast majority of buildings still use incandescent, fluorescent, or compact fluorescent bulbs. So there is a very substantial opportunity from either a business perspective or from a greenhouse gas and energy reduction perspective. All right, so we'll move on to the next section, 25. So slide 25. Okay, so sustainability. So this is pretty important contextually. So this definition, sustainability is a balancing act. Sustainability development must meet the needs of the present without compromising the well-being of future generations. Well, sounds very nice. It's also, unfortunately, incredibly true, meaning the things we do today really do affect not only us, but the future. And unfortunately, worse, the time to do this stuff is actually a lot shorter than what people had predicted and getting shorter every day. Then there is the classical phrase, think globally, act locally, which, by the way, I put some references in there about where that actually, what the origin of that originally was, which is from 1915. It's still true today, but much more so than would have been predicted in that framework. Next slide. So on this slide, this is just simply meant to be a reminder that because the amount of pollution or greenhouse gas emissions is so great from an energy perspective, energy generation perspective, all of these energy producing sources are either sustainable or they're finite, meaning if they use carbon fuels, for example, there's an endpoint, either economically driven or from a physical availability perspective for all of these things. So obviously, the more sustainable the energy sources are, they should also be, logically, less polluting in terms of greenhouse gas emissions. Next slide. We often speak about these in terms of zero net energy, but in fact, zero net energy is kind of a dated perspective. The idea of zero net energy is that you can generate as much energy as you consume. But that's not good enough. I mean, in order to be able to achieve any of these greenhouse gas reduction goals, they were going to have to be moving them towards positive net energy. In other words, sort of a micro generation capability in addition to the energy efficiency of the particular buildings, whether they're residential or non-residential. This is an entirely achievable thing, but it requires a very substantial investment in order to be able to get there, and the wherewithal for people to actually do this. Next slide. So here's the correlation. So there's three red circles on this slide. If you look at the bottom red circle, it says 0.524 pounds of CO2 per kilowatt hour multiplied by the total kilowatt hours saved. That is the shorthand version of what is the effect of saving energy. If you save electrical energy and it's coming from a grid source, meaning an electrical utility provider, almost without regard, but this is an average, but almost without regard to where that particular or how that energy is generated, you will save that amount of equivalent greenhouse gas emissions. So this is a pathway, a guide, if you will, a pathway to how to actually get to some of these goals and the time frames that we're talking about. It's a very difficult thing to do, but it's only a matter of scale. So if in fact codes and standards are in fact to be able to make sure that people use systems that actually cut down on emissions in the way that we're suggesting herein, you can get to these goals across all different systems. But it's not a small task, and it has to be something that's engaged by virtually everyone, as opposed to just a few heroic figures trying to make a difference. So it's a much broader based approach.